Question 1. If M is equal to matrices 1, 2 and 2 and 3 and M square minus lambda M minus I2 is equal to 0, then lambda is equal to, we have 4 options, that is A minus 2, B 2, C minus 4 and D 4. We have equation that is M square minus of lambda M minus of I2. We substitute the value of M, that is matrices, in the equation. We get 1. It is an M square, so we write M into M. For lambda into M, we get lambda, 2 lambda, 2 lambda and 3 lambda. Where I is a unit matrix. We solve this, we get as 5 minus lambda, 8 minus 2 lambda, 8 minus 2 lambda, 13 minus 3 lambda equal to Bishop unit matrix. On that side we get 1, 0, 0, 1. We compare this value with unit matrix, and that's why we get minus 5 minus lambda is equal to 1, 8 minus 2 lambda is equal to 0, 13 minus 3 lambda equal to 1, which we get lambda is equal to 4, which satisfies all three equations. We substitute all this in lambda, therefore the lambda value is equal to 4, which is option D. Option D is the correct answer. Question 2. If A is equal to cos alpha minus sin alpha and cos alpha, and B matrices is cos beta minus sin beta and cos beta, then the correct relation is A square is equal to B square, B A plus B is equal to B minus A, C A B is equal to B A, and D none of this. We first multiply, or we check the verification, that is AB cos alpha sin alpha minus sin alpha cos alpha into matrices B, that is cos beta minus of sin beta cos beta. We solve this, we get as cos alpha plus beta sin alpha plus beta minus of sin alpha plus beta cos of alpha plus beta. For BA also, when we multiply B into A, we get as cos alpha plus beta sin alpha plus beta minus sin alpha plus beta cos alpha plus beta. So therefore we can see that the matrices of AB and BA are equal, therefore AB is equal to BA, which is option C. Option C is the correct answer. We can also solve for A and B also. If we calculate, we don't get A square is equal to B square, or B is equal to A plus B and equal to B minus A. So we calculate for AB and BA, we get C. Therefore the option C is the correct answer. Question 3. If A is equal to matrice 1 0 1 0 1 1 and 1 0 0, then A is A symmetry, B skew symmetry, C non-singular and D singular. Therefore we check for matrices, that we take determinant of it, which we get minus 1, which is not equal to 0. That means hence the matrices A is a non-singular, which is option C. Option C is the correct answer. Question 4. If A is equal to 1 0 0 0 1 0 and A B minus 1, then A square. We have 4 options: A unit matrix, B null matrix, C A and D minus A. So we solve for A square, that is we A into A. We substitute the value of A, we get 1 0 A 0 1 B 0 0 minus 1 0 0 1 B 0 0 minus 1. We solve for this, we get 1 0 0 0 1. We it as unit matrix, that is A. Therefore, A is a correct answer. Question 5. If A is equal to 1, 1, 0 and 1, then A raised to n is equal to, we have four options, A, B, C and D. So we solve for A square, that is 1, 0, 1, 1, 1, 0, 1, 1. We get as 1, 0, 2, 1. And for A3, we know that it is A raised to n, so we solve for n. We get A square into A, that is equal to 1, 0, 2, 1, 1, 0, 1, 1. We know that A square, we have the value of 1, 2 and 0, 1. We substitute in this, we get as 1, 0, 3, 1. So we can see that if we calculate for A n, we get as A n raised to minus of 1 into A, that is, we see A cube can be solved as A square into A. So 3, that is 3 minus 1 is 2. So we take for A raised to n, that is n minus 1 into A. So we solve for this, we get 1, 0, n minus 1, 1, 1, 0, 1, 1. So for this, we solve this, we get 1, 0, n and 1, which is option A. Option A is the correct answer. Question 6. If 2A plus 3B is equal to matrices 2 minus 1, 4, 3, 2, 5 and A plus 2B is equal to 5, 0, 3 and 1, 6, 2, then B is equal to, we have four options, A, B, C and D. We write the equation 2A plus 3B equal to 2, 3, minus 1, 2, 4 and 5. We multiply 2 with the second matrice, that is A plus 2B, so that we further simplify, that is A plus 2B equal to 5, 1, 0, 6, 3 and 2. We multiply with 2, we get 2A plus of 4B equal to, when we multiply with 2 with the matrices, we get 10, 0, 6, 2, 12 and 4. Solving, let this equation be 1 and let this equation be 2. Solving 1 and 2, that we subtract 1 and 2, we get B minus equal to minus of 8, minus 1, minus 2, 1, minus 10 and 1. Therefore we get B is equal to 8 minus 1, 1, 10, 2 and minus 1, which is option B. Option B is the correct answer. Question 7. If the matrix 1, 3, lambda plus 2, 2, 4, 8, 3, 5, 10 is a singular, then lambda is equal to, we have four options, that is A minus 2, B 4, C 2 and D minus 4. From the question we conclude that the matrix is a singular, so therefore for matrix condition, that is determinant of 1, 2, 3, 3, 4 and 5, lambda plus of 2, 8 and 10, that is equal to 0 for singular condition. So we solve this, so we get as 140 minus of 40 minus of 3, 20 minus of 24 plus of lambda plus of 2, 10 minus of 2, that is equal to 0. So we solve, we get 2 lambda 2 is equal to 12, that is lambda is equal to 4, which is option B. Option B is the correct answer. Question 8. If A is equal to matrice 1 by 3, 2, 0, 2x minus 3, B is equal to 3, 6, 0, minus 1 and AB is equal to I, then X is equal to A minus 1, B 1, C 0 and D 2. So we solve for AB, we get 1 by 3, 0, 2, 2x minus of 3 and B matrice is 3, 6, 0, 1. So we solve for this, we get 1, 0, 0, 3 minus of 2x. We know that AB is equal to y, therefore we substitute this, that is AB is equal to y, we write 1 0 0 3 minus 2x equal to unit matrix, that is 1 0 0 1. So we compare the values of this matrices. We get 3 minus of 2x equal to 1. We solve for x, we get x is equal to 1, which is option B. Option B is the correct answer. Question 9. If A is equal to 1, 2, 3, that is row matrix, and B is equal to 3 by 3 matrix, then AB is equal to, we have 4 options in 3 by 3, also in column and rows. So we solve A into B. 1, 2, 3. We solve this, we get as minus 1, minus 2, 1, minus 4, which is option C. Option C is the correct answer. Question 10. If 2, 1, 3, 2 is a matrix into A minus 3, 2, 5, minus 3 equal to unit matrix, then A is equal to, we have 4 options A, B and C, D. We just need to find what is the value of A. So we're going to use verification method. For that we assume that let A, B, C, D be the matrix for it. So we substitute the value of A in the equation of the matrices, that we get as 2, 3, 1, 2. So we substitute the options in the A matrices for by, that is known as verification method. We substitute the option A in matrix A, we get as 1, 2. So we should get the unit matrix that is equal to unit. So we check for that. So we solve this, we get 1, 0, 0 and 1, which is equal to unit matrix 1, 0 and 0, 1. Therefore, we get equal matrix on left hand side as well as right hand side, that is unit matrix. Therefore, A is equal to 1, 1, 1, 0, which is option A. Option A is the correct answer. Question 11. If A diagonal 2, minus 1, 3, B diagonal minus 1, 3, 2, then A square B is, we write A square B is equal to A into A of B equal to, we solve for this, we get 2, 0, 0, 0 minus of 1, 0, 0, 0 and 3. Substitute all the values of matrices. We solve for this, we get as 4, 0, 0, 0, 1. We solve this two matrices, we get 0, 3, 0, 0, 0, 18. If you see, the diagonal elements are minus 4, 3 and 18, which is option B. Option B is the correct answer. Question 12. If A is equal to matrices 1, A 0 and 1, then A raised to 4 is equal to, we need to find a big, we have 4 options A, B and C, D, which is and matrices. We solve step by step, which is A raised to 4, that we can't multiply 4 matrices together, so we solve step by step, that is A square, that is A into A. We get as 1, 2A, 0 and 1. Now we calculate the value for A cube, that is A into A square. We multiply matrice A and the value of A square, that is matrice A square, and this we get as 1 0 3 A 1. Now we calculate for A raised to 4, that is A into A raised to 3. We substitute the value of A raised to 3 matrices and A raised to 2 matrices, so we get 1 0 4 A 1, which is option D. Option D is the correct answer. Question 13. If x is equal to matrice 3 minus 4 and 1 minus 1 and minus 1, then the value of x raised to n is, we have 4 options A, B and C, D. We solve for x, that is 3, 1, minus 4, minus 1. We take square of this, we get 5, 2, minus 8, minus 3. If we see clearly, when n is equal to 2, the matrices of A, B and C doesn't match. If we substitute value of 2 in n, that is 3 into 2, that is 6, minus 4 into 2, that is 8, n is a 2 and minus 2. So similarly we can substitute in B and C. So all the options, that is A, B and C, doesn't matches with matrices x square. So option D is the correct answer, that is D, none of this. Question 14. The value of x for which the given matrix, we have 3 by 3 matrix which is in x, will be non-singular. Or we have 4 options: A x greater than equal to minus 2, less than equal to 2. For B, for all x other than 2 and minus 2. C, x greater than equal to 2, and B, x less than equal to minus 2. We know that the matrix is a non-singular, which is determinant of matrix we will get as not equal to 0. So we solve this matrix, we get minus x of minus x the whole square minus of 2x minus of x square minus 2x plus of 2 minus of 4 minus of x square, which is not equal to 0. So for this we get 2x square minus of 8 greater than. We solve this, we get x square greater than equal to 4. Therefore x is not equal to plus minus of 2. If we compare this value of x, we get B for all x other than 2 and minus 2, because we know that this matrix is not equal to 0. So therefore we conclude that for all x other than 2 and minus 2. Therefore option B is the correct answer. Question 15. If A is equal to 2 by 2 matrix, that is I 0 0 and I. For B is 2 by 2 matrix, that is 0 R minus I 0. Then A plus B into A minus B is equal to. We solve where here we know that A into B is equal to I 0 0 and I 0 minus of I minus I and 0. We solve this, we get as 0 1 1 and 0. We solve for B A 0 minus I minus I and 0. I 0 0 and we get as 0 1 1 and 0, which is nothing but, if we compare these two matrices, we get AB is equal to BA. So therefore we can conclude that A plus B, A minus B is equal to A square minus B square, which is option A. Option A is the correct answer. Question 16. If A is equal to 2 by 2 matrix, that is x1 1 and 0, and A square is an identity matrix, then x is equal to, we have A x1 1 and 0. We know that A square is equal to 1, that is identity matrix. A square is equal to I. Therefore we solve for A square, x1 1 and 0, x1 1 and 0 equal to 1 0 0 and 1. We solve this, we get x square plus 1, so x and 1 equal to 1, 0, 0 and 1. We compare the matrices with the elements, we get x square plus of 1 is equal to 1. We solve for this, we get x is equal to 0, which is option B. Option D is a correct answer. Question 17. If A is equal to matrice of 2 by 2, where I is the unit matrix of order 2 and A, B are the arbitrary constants, then A into I plus B into A the whole square is equal to, we have four options A, B and C and D. So we solve for the equation that we have, plus of B A the whole square. We solve it, we get A square plus I square plus of B square A square 2AB. We use the formula A plus B the whole square. We solve it, this we get A square I square plus of B square A square plus of, we know that A into I is nothing but A. We have A matrices, that is 0, 0, 1 and 0. So when we take the square for A square, we get 0, 0 and 0. So we know, so we conclude that A plus B, B plus A the whole square is equal to A square I plus of 2AB A. So for A square, that is unit, we get 0. That is when we substitute the value of A square in equation, so we get B square into 0, so that the B arbitrary constant gets away, so we are left with A square into I 2AB A, which is option A. Option A is the correct answer. Question 18. If A is equal to matrix 2 by 2 and for B is 2 by 2, for A is 1, 2 and minus 3, 0, and for B minus 1 and 0, 2 and 3. Then we have four options, that is A square is equal to A, B square is equal to B, C AB not equal to BA, and D AB equal to BA. We solve for every option, that is A square, we get is 1 minus 3, B is 0, 1 minus 3, 1, 0, we get minus 5, minus 3, 2, minus 6, which is not equal to A. So therefore option A get cancelled, which is to be assumed. For B we calculate minus B 2, 0, 3, minus 1, 2, 0 and 3. We get 1, 4, 0 and 9, which is not equal to B. So therefore option B also get cancelled. We solve for A to B. We get 1, 3, 2, 0, minus 1, 2, 0, 3, equal to 3, 3, 6 and 0. For B, A, minus 1 and 2, 0 and 3, minus 3, 1, 0, equal to 2, minus 1, minus 7, minus 2, 4. We see that AB, that is A to B matrices, is not equal to BA. So we can say that option C is the correct answer. Question 19. If A is equal to matrix 2 by 2 and I is equal to matrix 2 by 2, that is unit matrix, then which one of the following holds for all n greater than equal to 1 by the principle of mathematical induction? We have four options A, B and C and D. So we solve for A square. So we get 1, 1, 0, 1, 1, 1, 0, 1 equal to 1, 2, 0, 1. Please know that we are solving for A square because in all the option it is A raised to n. So we can solve for A square, A cube or A raised to 4 also. So we that is a raised to n, where n stands for 1, 2, 3 and 4. Therefore a raised to n can be the answer of 1, n, 0 and 1. If we compare this matrices of 2, that is a square and a3, the value that is element of a to 1 is getting changed, so we write as n over there, that is the order of a. So therefore n into a is equal to n, 0 and n. We multiply with I also, that is n minus 1. If we see the options, we have n minus 1 I in every option, so we have to calculate for that. So we get n minus of 1, 0, 0 of n minus of 1. So we minus this two equation, that is equation of 1 and equation of 2. We get n into n minus of n minus 1 I is equal to 1, 0 and 1, which is equal to raised to n. If we check the option, that is a equal to a raised to n equal to n, a minus of n minus of 1 into I, which is option C. Option C is the correct answer. Question 20. If 1 into 1 into 3 by 3 matrices into x 1 minus 2, that is a column matrice, equal to 0, then x is equal to. So solve this matrices together, we get as 1, 2 plus 5x, 3 plus x plus 2, x 1 and minus 2 equal to 0. We solve this, we get as x plus of 2 plus 5x plus of 3 plus of minus 2, 3 plus x plus 2 equal to 0. Therefore we get value x is equal to 5 by 4, which is option C. Option C is the correct answer. Question 21. If aij equal to half of 3i minus of 2j and a is equal to aij of 2 into 2, then a is equal to, we have four options, a, b and c, d. A we have half, 2 minus half and 1, b half minus half, 2 and 1, c 2, 2 half minus half, and d none of this. So we have a of aij half of 3i minus of 2j. So we know that a11 is equal to half, a12 will be 1 by half, a21 we have 2, a22 is equal to 1. We see that I and j, we substitute the value of I and j for a11. So for I will be 1 and for j equal to 1. So we substitute this value of 1 and 1 in this equation, so we get half. Similarly, we get a12 is equal to minus half, a21 is equal to 2 and a22 is equal to 1. So for a is equal to aij 2 by 2 matrices, a11, a21, a12 and a22. We get as a is equal to half of 2 minus of half 1, which is option B. Option B is the correct answer. Question 22. If A is equal to 2 by 2 matrices and Ft is equal to t square minus 3t plus 7, then Fa plus of 3, 6 minus 2 and 9 is equal to, we have 4 matrices A, B and C, D. For A we have 1, 1, 0, 1, B 0, 0, that is 0 matrices. For C we have unit matrix, and for D it is 1, 1, 0, 0. So we solve, we know that A is equal to 1, 4 minus 2 of 5. We have equation of f of t, that is t square minus of 3t plus of 7. We substitute value of A and that is in the place of t, we get a square minus of 3t plus of 7. We solve for this, we get we solve for a square, we get 1 4 minus 2 5, 1 4 minus 2 5 equal to minus 7 24 minus 12 17. So we solve this, we substitute all the values, that is a square and a in the equation, that is f of a plus of f of a plus of 3 minus 12 6 minus 9 equal to, we solve this, we substitute the value of f a. When we solve this, we get as 3 minus of 12 6 and 9. So we substitute in this, we get as we see that we get, please note that for FA we get matrix minus 3 minus 6 plus 12 and 9. So we substitute this in equation of our FA, that is plus of 3 minus of 12 6 and minus 9, we get 0 0 0, which is option B. This is 0 matrix. Option B is the correct answer. Question 23. If 2 plus x 1 x 3 minus 1 1 4 2 minus 5 is a singular matrix, then x is, we have four options: A 13 by 25, B minus 25 by 13, C 5 by 13, and D 25 by 13. So we take matrice, that is determinant of 2 plus x 1 and x 3 minus 1 1 4 2 and 5 equal to 0, which we know that it is equal to singular matrix. We solve this, we get as 2 plus of x 5 minus of 2 minus of 3 minus of 5 minus of 2x plus of 4 1 plus x is equal to 0. We get 6 plus of 3x 15 plus of 6x 4 plus of 4x is equal to 0. We solve this, we get 13x is equal to minus 25, which is x is equal to minus 25 by 30, which is option B. Option B is the correct answer. Sorry, this is minus 25 by 13. This is option B. Option B is the correct answer. Question 24. If a matrix A is equal to 0, minus 1, 1 and 0, that is 2 by 2, then A raised to 60. So we have A is equal to 0, 1, minus 1 and 0. We solve for A square, that is A square is equal to A into A, 0 1 minus 1 and 0, 0 1 minus 1 and 0, that is equal to minus 1 and 0, 0 and minus 1. Therefore, for A raised to 16 can be A raised to square to 8. So we solve for minus 1, 0, 0 and minus 1. We substitute the value of A square. We get A raised to 8. So we get minus 1 the whole raised to 8, 0, 0 minus 1 the whole raised to 8, which is equal to 1, 0, 0 and 1, which is option D. Option D is the correct answer. Question 25. The matrix 3 by 3, that is 2 lambda minus 4 minus 1 3 and 4 1 minus 2 and minus 3 is a non-singular if A lambda not equal to minus 2, if lambda equal to 2, B, that is C, lambda is not equal to 3, D lambda not equal to minus 3. We solve the matrix which we know as the matrix A is not singular, therefore we know that determinant is not equal to 0. So therefore determinant of A is equal to determinant of 2 minus 1 1 lambda 3 minus 2 minus 4 minus 4 3 matrix equal to, we get 1 minus 1 1 lambda plus 3 3 minus of 2 0 4 minus of 3 matrix. So we solve this by shifting of rows and columns. So we shift, we do R1, that is R2 plus of R1, we get 1 0 0 lambda plus 3 1 minus lambda minus 5 0, 1 minus of 3. The second step will be shifting of R2 and R3 together. R2 plus of R3, R3 minus of R1. We get as please note that R1, R2 and R3 we together do it, so we get the matrix. The final matrix is 1 0 0 lambda plus 3 minus lambda minus of 5 0 1 minus of 3. So the shifting of R1, R2, R3 result to this matrix, that is 1 0 0 lambda plus 3 1 minus lambda of minus 5 0 1 and minus 3. So we solve this for lambda is 1 minus 3 of plus lambda plus of 5 not equal to 0, which we get as lambda plus 2 not equal to 0, therefore lambda not equal to minus 2, which is option A. Option A is a correct answer. Question 26. If A is equal to 3 by 3 matrix, that is unit matrix of diagonal 1, then A square plus 2A is equal to, we have four options: A, B 2A, C 3A, D 4A. So we solve this, we substitute the value of A in the equation, that is A square plus of 2A, so we get as 1 0 0 0 1 0 0 0 1 into, that is A square 1 0 0 0 1 0 0 0 1 plus of, when we multiply with 2 with this, we get 2 0 0 0 2 0 0 0 2. We solve this, we get 3 0 0 0 3 0 0 0 3. We take 3 as a common, we get 3 1 0 0, which is nothing but this matrix is 3A, which is option C. Option C is the correct answer. Question 27. M is equal to 3 by 3 matrix, that is 1 1 1 and 1 1 1 and 1. For m raised to 50 equal to, we have A 3 raised to 49 by m into m, B 0, C minus 1 and D 1. So we solve for step by step, that is m into m, that is equal to m square. We get as 3 3 and 3. That is, we take common as 3 out, that we get 1 1 1 1 and 1 1 1 and 1, which is this matrix is equal to m, we write as 3 into m. Now if you see, if you multiply m into m, we get as m cube. So for that we can do as 3 into 3 directly, 1 1 and 1 equal to 3 square of m, that is 9 of m. So we conclude that when it is m square, we get 3m. When it is m cube, we get 3 raised to square into m. So we can say that m raised to 50, sorry, that is m raised to 50 can be 3 raised to 49 into m. That is, we conclude that m raised to n, 3 raised to n minus of n into m, which is m50 is equal to 3 raised to 49 into m, which is option A. Option A is a correct answer. Question 28. If A is a square matrix such that A square is equal to A, then A minus A cube plus A is equal to, we have four options: A as A, B I minus A, C A I, D 3A. We know that A is a square matrix such that A square is equal to A. So now minus of I cube plus of A is equal to I minus of A the whole square, I minus a plus of a. We solve this equation, we get as I square minus of 2a plus of I square minus of 2ai plus of a square I minus of a plus of a. I square is nothing but I. A into I is a. The a square is nothing but a. I minus of a plus of a. We get this as minus of a minus of a plus of a. So that is a minus I minus a is nothing but I square minus of 2ai plus of a square. Similarly, we know that I square is nothing but I. 2 into I is 2, that a into I is a plus of a square is a plus of a. We get this as I minus of a plus of a. I minus of a plus of a. So therefore equal to we get this as I minus of a plus of a, which we get a cancel, which we are left with I. Therefore I minus of a the whole cube plus of a is equal to, that is option C. Option C is the correct answer. Question 29. If A is equal to 2 by 2 matrix, that is x 1 and 1 and 0, and A square is a unit matrix, then the value of x cube plus x minus 2 is equal to, we have 5 options: A minus a, B minus 2, C 0, D 1, and E 8. We solve for a square, x1, 1 and 0, x1 and 1 and 0. We get this as, we solve this, we get x square plus of 1, x of 1. So where a square is a unit matrix, we get x square plus 1 is equal to 1. We solve this, we get x equal to 0. So for x cube plus of x minus of 2 is equal to minus 2, which is option B. Option B is the correct answer. Question 30. If A is equal to 3 by 3 matrix where all the elements are 1, then A raised to n is, we have 4 options. We solve for A square, 1 1 1 and 1. So we solve this, we get 3 3 3 3. So we conclude that A cube can be the matrix of 3 square 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 and 3 square. So for A raised to n can be 3 raised to n minus 1, 3 raised to n minus 1, 3 raised to n minus 1. Which we can see that when A is square, it is 3, which has order 1. So we conclude that A cube can be the 3 square. So A raised to n can be n minus of 1. So which is option B. Option B is the correct answer.